Welcome to the Empire Excel video tutorial series narrated by Dr. Andreas Wien, Customer Support Team. I will give you a basic introduction on how to start with the software. Here the meshing and simulation parameter aspects will be discussed. Here an example is loaded which shows a Vivaldi antenna. The model consists of 3 metallization planes which are fed by a triplate line port. Between the metallization layers we have a dielectric support. Now let's create a basic mesh. By pressing this button, an automatic meshing will be started. The mesh lines are indicated on the right and on the bottom. We can check the meshed structure by pressing this 3D button. Here we see the meshed model with the staircase approximation. Now let's return to the draft mode and create a finer mesh. Therefore we go to the mesh options. By default a medium size resolution is set. Now we enter another value and create a new mesh. As can be seen, the approximation is now much better. Now let's check the meshing in the perpendicular direction. As can be seen, the grid lines end at the boundaries of the structure. But for antenna structures we usually require more space to the boundaries. This is done automatically if we define a far-field recording. Far fields are defined in the Field Monitor section. Before simulation, we only need to define the frequency. Now let's create a new mesh. As can be seen, some grid lines have been created at the outside. It is also possible to manually adjust the edit space. At this point we can specify the additional space. As an example, we add additional space at Y max, which is the main radiation direction. This was an introduction in the main meshing options. Now let's have a look at some important simulation parameters. In this window, the most important simulation parameters can be set. By default, the unit is micrometers, but can be adjusted here. Here the solver can be selected. By default it's EM solver. As already available in the mesh options, the resolution can be set here. The excitation response determines the end criterion. It defines the number of time steps and the energy decay. Here, the perfect geometry approximation can be switched on or off. Especially for curved structures, this option should be enabled. If the PGA is enabled, we can also use a coarser mesh. The start and end frequency determine the frequency range of the DFT. By default, losses are neglected. If they should be accounted for, we have to enable here. At last we can select the boundary type for each side. The absorption quality of the open boundaries can be adjusted. Thank you very much for your attention. If you have any questions or comments, please contact your local support team. We highly appreciate any feedback or suggestion on further topics.